everyone, welcome to STEMpassion's YouTube channel. My name is Aditi and I'm a rising junior from New Jersey. I made this channel to address the lack of women in STEM because us girls need to rise up to our full potential. So let's get to today's video. First of all, what is STEM? STEM stands for science, technology, engineering, and math. For today's video, we're going to focus on science, and our first lesson is going to be about pedigrees. Pedigrees are diagrams that show you how traits are passed down through generations. Some examples of traits are dimples and freckles. So different people can get different traits because of genes. There are recessive genes and dominant genes, and I'm going to do a quick review on those. You receive one allele from each parent for a trait. This allele is random because parents also have two alleles for the same trait, and one of the two randomly go to the child. You need two recessive alleles, which are shown by lowercase letters for a recessive trait to show. That means that both of your parents need to have at least one recessive allele for you to get a recessive trait. For example, a type of flower could have white petals as their recessive trait. So both of the parent flowers would have to be white or have at least one white allele for the baby flower to be white. If you have two recessive alleles and two recessive genes, then that's called homozygous recessive. Homozygous just means two of the same allele. Dominant traits are the opposite, and they're represented by uppercase letters. Dominant alleles only come from one parent, or only need to come from one parent to appear in the baby, because just one dominant gene can mask a recessive gene, and that's why it's called dominant. You just need to remember that a capital letter overpowers a lowercase letter in a gene. So if the same flowers we were talking about before had purple as their dominant trait, then two purple parents could make a purple baby. This baby would be homozygous dominant. Remember that homozygous just means two of the same allele. So back to our example, one homozygous dominant purple and one white flower would also make a purple baby because the purple is dominant and it masks the white. If the baby has one purple and one white allele, then it's called heterozygous. That just means that it has one recessive and one dominant allele. So now that we know that, let me show you how that relates to pedigrees. Most of the time, pedigrees are used to show how diseases show in families, so scientists can figure out whether a disease is dominant or recessive. And this is how they do it. First of all, every person in the family is described with a white, black, or half white, half black shape. Girls are represented by circles, and guys are represented by squares. It's important to show whether each person is a male or female, because some diseases only go to either male or female. So including that in the pedigree can check to see if it's a type of disease that only affects one of the two. If the person's shape is white, that means they don't have the disease. If the person's shape is black, that means they do have the disease. And if the person's shape is half white, half black, that means that they have one recessive and one dominant allele, so they're heterozygous, and they're called carriers. People that are carriers don't have the disease, but they could pass the disease to their kids if their kids get the disease allele instead of the non-disease one. So if we see these symbols, this is a female with no disease, this is a male with a disease, and this is a female that's a carrier. Next, there's lines in between these symbols on a pedigree chart. The horizontal lines show that two people are married, and the vertical lines show the next generation, meaning that they had kids. So normally, if you start with two people, you would make a horizontal line between them to show they're married. Then you make a vertical line down to start the next generation. Then you make another horizontal line if they have more than just one kid, just to keep it organized, and then add a vertical line for each kid. Trust me, it gets a lot easier after you get used to it. So lastly, I want to show you guys how to interpret a pedigree. Here is an example of a pedigree, and we're going to pretend that the disease allele is dominant for our example, but it could be recessive too in real life. The two people that we're starting with at the top are heterozygous. Remember, that means that they have one recessive allele and one dominant allele. So that means they're both carriers and they don't have the disease. This boy got the disease allele from both parents, so that means he has the disease. Since our disease allele is dominant, that means he's homozygous dominant. For the first and last kids, they got the disease alleles from one parent and the non-disease allele from the other. But we have no way of knowing which parent gave them the disease allele just by using a pedigree. They're also heterozygous and carriers. The third kid got super lucky because she got the non-disease allele from both parents. So she doesn't have the disease and she's not a carrier either. That means she's homozygous recessive because the recessive allele is the non-disease allele. So that's all for this pedigree. Before I finish this video, let me just recap the vocab terms from today. We learned about recessive alleles, dominant alleles, homozygous dominant, heterozygous, homozygous recessive, and carriers. If you got this far, then great job. I know it was a lot of information, but hopefully this video helped. Subscribe if you want more videos like this, and comment on any topic you want covered next. Thanks for watching. Bye!